Yancy, I've got quite they're busy slides, so I'm going to try and work through them quite quickly.
Okay.
But the underlying idea here is to try and take a couple of new so-called disruptive technologies and put them together in a new way that maybe we can try and start to solve some of the energy poverty problems around Joburg. So what I'm presenting is a proposal for supplying energy to urban informal communities using a blend of old and new technologies. Right. So the city expects us to provide energy services for people living in these informal settlements. And they've tried to put a policy together, but it's been quite a challenge, I must admit. But what they've got so far, it focuses on supporting alternative energy solutions that would include lighting, cooking, and heating for informal settlements, but also from the point of view that it's a temporary or an interim measure. There's certain issues around the MFMA. We're not supposed to put permanent infrastructure into areas that are deemed temporary, even though some of these places have been around for an extremely long time. So just to give you an idea of the scale of the problem, Joburg alone has around 312 informal settlements with over 180,000 structures within them. They're not connected to the grid. The city does have programs in place where we try and upgrade and electrify informal settlements, but we can only do that where it's legally permitted to do so in terms of the land ownership as one of the criteria, for example. And the idea is that you go into an informal settlement and you start to normalize it by putting roads and access ways in, and also assigning the plots, if you like, within the area, and formalizing it from that point of view. Once you've formalized it, you can then go and put in the normal 3 kVA AC service connection. If we were to do that for all 312 informal settlements, we would need another 600 megawatts worth of bulk infrastructure. In other words, substations, input substations from Eskom, the infrastructure below those substations, etc., to feed these areas. And as I've mentioned, some of them are 20 years old. So there's definitely a need for a relocatable and a reusable household energy delivery system as a precursor or permanent solution, perhaps, to formal electrification. And that's really what the presentation is about. So these are the challenges that we've got at the moment. We've got illegal service connections, community tension, and electrocutions, unfortunately. So you see this unsafe 240-volt AC legal service connection wiring in informal settlements. Serious hazard for residents. We do, unfortunately, electrocute several people every year, and in particular children. We also have the problem that these illegal service connections overload the surrounding areas, and that causes numerous outages. And again, tension within the communities, the informal and the formal communities. We've also got these mafiosi-style illegal service connection operators that come in. They don't charge a monthly fee, but they'll come in and they'll charge an exorbitant fee to be connected illegally to some supply point. Okay, and of course that's a loss for City Power, a loss for any distributor. And the irony is that we rinse and repeat this. I mean, we regularly go in, our risk management people go in, they remove the service connections, and it only recreates the opportunity for this mafioso to go back there and put a new illegal service connection in. So I think there's also a need for a safe energy solution that can outcompete these illegal operators. That's where we try and get to. So what have we got? The old technology, and I think sometimes we really take the grid for granted. The interconnectedness of an existing grid is a very high value enabler, if I can put it that way. As you connect many different types of load, the system benefits from demand diversity. So you change the shape of the total load, and you end up having to design for the cheaper and not the most expensive option. The same grid is open to supply diversity as well. We can connect plenty of distributed energy resources to our networks. And when you couple energy storage with a grid, you also enable temporal demand and supply side diversity. You can now start shaping that load profile to exactly what you want it to be. The other issue is that, or plus benefit, is that this grid, certainly within an urban area, surrounds most of those informal settlements already. And if you look at it, energy is already flowing into those communities through the illegal service connections. If those energy flows could be properly controlled, the grid would also be the cheapest form of backup energy for any clean energy solution that you want to try and implement. It also means that if you think of the grid as connecting everything together, any large rooftop, such as a warehouse or a factory building that's already connected to the grid, enables us to access cheap, clean PV power with virtually no capital expense. And we know that our urban medium voltage cable networks have a good hosting capacity. We haven't seen problems yet, and we've seen some pretty big systems, shopping centers, for example, that have put anywhere between 3 and 5 megawatts on the grid, and the grid is able to absorb it. So on the new side, the new technology, DC distribution systems, modern DC distribution technologies overcome the problems of switching and fault arcing. You've got switch mode power supply technology that's really mature. You know, your PC on your desk wouldn't have been possible without a switch mode power supply for its size and efficiency. And the same technology enables this DC distribution. And you can also now have DC arc detection and circuit shutdown protection if there is an arc somewhere along, either through a short or a switching fault on the networks. An extra low voltage DC distribution, as it's defined by IEC, is less than 120 volts DC, and there's a low electrocution risk to it, so we can steer things towards non-lethal grids here. Nothing prevents the conventional AC grid also from being the energy source for an embedded DC distribution system. And also, of course, power line carrier technology, the communications works over DC distribution systems as well, enabling things like alarms and simple vending and tamper detection as well. New tech, the clean and cheap new sources of energy. Levelized cost of rooftop is about R1.30 per kilowatt hour, and it should last for 20 years. The average cost of Eskom power has now just gone up. It's close to R1.75 per kilowatt hour, and those costs are likely to carry on escalating as time goes by. And what you're also going to find is that the network and demand charges that Eskom charge are also likely to escalate at an even higher rate, because they've got to now accommodate the new peakiness of the demand, if you like. And that will drive the need on our side for a corresponding investment in energy storage in any renewable energy project. We've got to really start thinking seriously about co-investment with storage and renewables. And in Joburg, certainly we've got hundreds of secure rooftops that are quite capable of hosting 0.5 megawatt PV systems, and they're already connected to the grid. Energy storage technology, I think this is where the leaps and bounds have actually happened. So the old lead acid battery technology had very limited life cycles. Typically, if your depth of discharge is 40%, you could expect 500 cycles. I know they are doing a lot of work on lead acid technology, and some of them are getting up to 4,000, but it's a blend of new technologies. We haven't quite seen that yet, but there is work going on that basis. But if you've only got the 500 cycles, your system will be finished within 2 years. And this is where lithium-ion battery technology has already overtaken lead acid in that regard. So lithium-ion typically has a 5,000 cycle at a depth of discharge of anything up to 80%. So it's a lot more usable from that perspective. And that would mean a 10-year useful life before you would need to replace it. We also see a lot of horizon stuff in terms of sodium technology may overtake lithium, be a lot cheaper, and be more suitable, of course, for stationary applications. The lithium technology is very light and compact and energy dense, so it's suitable for electric vehicles, for example, but there may be other technologies cheaper that are more suited for stationary applications. And also supercap technology is also developing fast, although it's very expensive at the moment. The cost should come down in the future. DC appliances and induction cooking. So the USB-C connection, the one you use on your cell phone these days, if it looks like that little round one and not the old D-type one, that is capable of delivering up to 100 watts of power, 5 amps at 20 volts DC. So within a residential setting, for example, this can be used to connect various appliances up to an energy storage system, for example. And those appliances can include cell phone charging, efficient LED lighting, TV satellite decoders, and entertainment systems. Induction cooking technology is also mature and one of the safest methods of cooking and heating water. However, that technology does require cookware that's manufactured from materials that have a component of ferrous metals in them, but they're quite readily available already. So we get to the point where we have to ask the question, what would be a useful amount of energy? And you see an energy budget on the right-hand side there, where we list things like an outside light, an inside light, cell phone, TV decoder, TV screen, internet tablet, and an induction cook plate, or you could in theory use a conventional hot plate as well. But you come to an amount of around about 3 kilowatt hours that you would need to make a useful difference, I think. And it's part of the problem here is to convince the community that might use this that this is worth having. It's not the full grid connection, but it's worth having from the point of view that it can provide the high value utilities like lighting, like cell phone charging. I mean, that's essential in today's world, even for somebody that lives in an informal settlement, absolutely necessary, as well as things like tablets and entertainment that have a high social value. We know that the electric cooking appliances require substantial energy, and I think that would be the first thing that you would want to have. Refrigeration is a nice, convenient facility to have as well, but maybe not essential from this perspective. And space heating requires an enormous amount of energy. And there we would propose alternative means of personal heating, clothing and hot water bottles, for example. So our proposed solution is we want to take microgrid elements and just rearrange them into a new form where we can embed the system within the conventional grid. So the idea is to develop a rugged appliance box that will be registered and issued to each house and kept as assigned property within the dwelling. It will still belong to the utility. If it goes faulty, we would simply replace it. That's the idea behind this. And each energy box will contain 3 kilowatt hours of energy storage that is charged by means of a constant supply of 130 watts only of non-lethal DC electricity through this informal wiring network. The DC grid will be supplied energy from the conventional AC grid that's around it through an AC to DC converter. And that box will also have communication equipment in it and intelligence that it can shut down in the event of a fault. The DC grid will also be used for the communications for vending, etc., and alarming, for example. And the energy box can be enabled by control signals from those units, so you can remotely switch them off, similar to what a smart meter would do as well. In the scheme, renewable energy is included in the proposed solution by using any suitable warehouse type rooftop that's connected to the normal AC grid. Okay. And we can size that PV system to offset the full cost of the energy provided to informal settlement. So that's one of the benefits of the grid, is that it has this diversity. Even though we know that the sun goes down at night and the energy required by the informal settlement will be drawn from the conventional grid, during the daytime we can triple the amount of energy that the PV panel gives, push it into the grid. It will be consumed by businesses that are on the network during business hours, and we can simply offset that against the evening consumption. So it also enables the use of larger and more economically viable rooftops to provide a portion of the energy required in fact, to provide all of the energy required from clean sources. So here's the diagram of what it would look like. On the left there, you see we've got the factory building with the PV panel on it. That supplies power into the grid. And that conventional grid supplies the formal AC reticulation houses on one side. And on the other side, we have these converter units that convert the conventional AC grid into DC. And we have this informal wiring system that runs through the shacks and dwellings to connect them up. And you don't need big wire here because you're going to limit it to 130 watts. So the charge, if you look on the right-hand side, you'd see that charging current would then only be 1.3 amps per house, which is far less. You need far less cable network, if you like, to make that happen. Then, of course, on the right there, you see the liters boiled per day, up to 12 liters. That's what we budgeted for. 60 minutes of cooking time. We'd run the system at not more than 120 volts. Storage efficiency is pretty good with lithium ion. You're at about 90%. You can take that into account as well and build it into your design. The wattage of the charging system is 130 watts. The current required per house is 1.3 amps, which is doable. You could conceivably even put up to 10 houses on your normal 1.5 or 2 millimeter cab tire type of cable, extension lead cable, for example. The other beauty of this is that it would enable us to take one standard service connection, which is normally a 5 kVA service connection, and share it out between up to, I would say, 30, not 39 units. Perhaps you could go as much as 30. But all of a sudden, you take one standard service connection and you share it between 30 shacks, if you like, or 30 dwellings. And that takes away this requirement of having 600 megawatts worth of new infrastructure down to somewhere around about 30 megawatts, which you might even be able to find by scrimping and scraping with what you've got installed already. So that's the concept behind it. And then, of course, it would have this energy box that includes the energy storage system. It has the ports to connect the lighting, the cell phone, and the TV to, and it would have the induction cook plate that could also be on a fly lead that connects to the unit. So the proposed solution, providing the energy to the household, the lighting and devices connected to the box will only be DC powered devices, not AC powered devices, using the USB standard, USB-C standard. It'll be equipped with an induction-based hot plate for boiling water and cooking. Energy box will also have a control system so that the user can manage their daily consumption, and will use power line technology to communicate with the unit. So the benefits for us here are also quite significant. So because we use a constant controlled amount of power from the grid, we don't have the evening peak issue that a normal AC service connection would suffer. So it flattens that evening peak. If we're going to subsidize these communities, it doesn't make sense to use the most expensive energy to subsidize them, because their consumption is pretty much during their morning and evening peak. So this is a way to now offset some of that subsidization, if you like, by controlling and reducing that evening peak to a manageable dimension. Use of non-lethal voltages should eliminate the electrocution risk. The roll-up and relocate concept will not violate MFMA rules that be about permanent infrastructure. And we can only dispense a fixed amount to each household per day. Normal service connection with a meter bypassed, you can consume easily 72 kilowatt hours per day. That's a huge loss for city power, where this system now limits the amount of energy each house can get to 3 kilowatt hours per day. And we can argue that all the energy generated for the informal settlement is green or carbon neutral. And it also will not be subject to any future Eskom prices. Once you've paid for the PV panel, it's the capital cost only. So there's only the cost to maintain it from the point of view of keeping it clean, which is a relatively small cost. So you've now got an energy source that doesn't escalate at Eskom price increase rates. The idea also was that because it's non-lethal DC, you don't need proper, fully qualified electricians, and you can perhaps create a formal job of a serviceman, if you like, that can go into that or live within the community and maintain the system from within. And it can also be used to solve the backyard shack problem. So the next step is we want to get to a point where we develop a pilot. From a financing and sustainability point of view, I think we can get enough funding from INEP Capital, the Electrification Fund. We can use the equitable share for ongoing maintenance, and also an affordable, dignified nominal payment for services. It's a fixed cost energy source, so it's in that respect, it's self-subsidizing and a sustainable solution. We have done some work already with the community, together with the City of Johannesburg and the C40 organization, where we've done a survey in the settlement, and the community seemed very positive towards it. So it tells us that it wouldn't be rejected from the point of view that it's not the full grid, if you like. So what we need now is some system development and prototyping. So we're looking for some venture capital at the moment. I'm trying to convince our colleagues at City Power to make the investments. They're scrimping and scraping. Um, a lot of our capital, for example, is required just to keep our networks going properly. So anybody with venture capital, please give me a call. I'd really value it. And we need a technology and manufacturing partner. I think, what we've seen in the past are, I call them toys. It's a solution that's a battery with a PV panel and a couple of light bulbs and a cell phone charger. And then we issue that to an informal settlement dwelling. And the minute that gets hungry, the stuff gets sold. So what we need is a utility grade solution here. And also one that's going to be maintained properly. And that's what we're proposing, Nancy. Thanks a lot, man.